We will see algorithm design techniques. Then how we can write algorithm. What are the techniques, methods available for writing algorithm? So when we write an algorithm, we must understand the problem thoroughly and we have to decide what type of data structures we are going to use to develop algorithm and what type of designing methods we are applying to solve the problems. And algorithm design techniques are fundamental strategies used to develop different efficient and effective algorithms. Each of these techniques has its own set of strength and weakness, and not the choice of techniques depends on the nurture of the problem, required performance, and available resources. And here, when we choose the design technique, we have to concentrate on the method or what type of solutions we need, and whether it is possible to divide the problem into subproblems, or whether the problem can be solved in multiple stages or multiple steps, and nature of the problem and the type of input data sets, and understanding and mastering the techniques can significantly improve the ability of designing efficient algorithms. So before designing algorithm, we must understand the requirement, performance, and available resources, and the nature of the problem. And what are the techniques available for solving the problems? Divide and conquer method. So in this divide and conquer method, if the problem is too large or too complex, we can divide the problem into n number of sub-problems, and the sub-problem can be solved independently. And finally, the solutions can be combined to get the solution to the original problem. Example, binary search, quick sort, merge sort. These type of problem can be solved using divide and conquer method. And dynamic programming. Dynamic programming, if subproblems occurs more than one in a solution space, we can go for dynamic programming. Instead of executing the subproblem again and again, multiple stages, the subproblems can be executed and the results are stored in a table. Whenever the subproblem comes, instead of re-execution, we can take the result from the table. And this is, it avoids the recomputation, redundant computation of subproblems. That will increase the complexity, performance level, and decrease the complexity of algorithm. And greedy approach. What is greedy approach? The problem is solved in multiple stages, and each and every stage we are searching the local optimal solutions. So that will lead to global optimal solution. So it has disadvantage. So local optimal solution does not give global optimal always. There may some cases it can have um, issues. And what is the backtracking? For one problem, there are n number of solution choices are available at a one stage. So we are choosing the best choice and each and every stage. And this can be identified, and we can expand the local best solution to the next level. And here, if we are going in multiple path, if one path does not lead to a correct solution or does not give a feasible solution, so we can stop the process at the end, at the current stage. It's called dead end. Dead end does not lead to a solution. So in this case, what we can do, we can stop the process at the end, then we can go back to the previous stage, then we can find the alternate solutions. It's called backtracking. If one path does not lead to optimal solution, it's not possible to give solutions, we can stop at the current node, then we can go back to the previous, we can find the other options. And if this type of problem can have more than one solutions, and it may have zero solution also. For example, n-Queen's problem, Hamiltonian problem, subset sum problem, that problems can be solved using backtracking concept. And what's a branch and bound? And divide the problem into smaller branches. and calculate the bounds. That is maybe lower bound or upper bound. For minimization problem, the value should be lower bound we are taking. For maximization problem, the node value should be maximum. The maximum value node that can be taken, that can be expanded to the next level. And so that's called branch and bound. Branch, go to the multiple parts and choose the best, either lower bound or upper bound, that can be expanded to the next level. This process is repeated till we find the optimal solution to the complete problem, whole problems. And randomized algorithms. Some random numbers can make the decisions within the algorithm. That's called randomized algorithms. So there are 3, 6, 7, and so more approximation algorithm is there. So there are different methods available for solving problems. So we have to understand the background of the problem and the background knowledge of the problem, and we have to decide which type of data structures and which type of designing methods we are going to apply to solve the problem. That's called algorithm design techniques. And so divide and conquer method, divide the subproblems in problems into subproblems and solve multiple stages. Example, MakeSat and QuickSat. That is, it uses recursive call functions. It gives always order of n log n time complexity. And the brute force. This is a very basic approach. It's a brute force approach. Here, all the possible solutions are from the problem statement. The problem solution, the statement that can be implemented as such without any optimization method, without applying any methods. The solution space, the solution statement is implemented as such without any optimization. And backtracking. Backtracking is the method for solving problems in multiple stages. If one stage or one path does not give the optimal solutions, we can go back to the previous and we can find the other options. That is Sudoku and n-Queen's problem. Here state space tree is developed, and there are two ends in the state space tree, dead end and solutions. Dead end means that current path does not give a optimal solutions or feasible solution, and some path gives solutions. It's called solution end. For this technique, that can be applied if the problem has more than one solutions and another multiple possibilities.